So this lesson will be talking about the computer history, just to give you an idea about how computing moved on from the year before until today. Good. So what is computing? Good. Computing is the act of a process and compute. It's the act of actually getting something calculated or getting something compute or calculated or processed. Good. When you say computing, technically computation is the name, computing is the verb of that or another name for it. How do you compute that? How do you calculate that? We don't say calculate, we say compute, because it's not only about numbers. Sometimes you have to process text, sometimes you have to process other stuff. Okay. So let's start with this and let's test if you guys will participate with me or leave me alone. Good. What do you think is the first computer that a human used? Not computer, computing machine. What is the first computing machine that a human used? Sorry.
I think the first one was in World War I, when the Brits broke the code for the Germans and they used this really big machine.
No, this is too far away. This is too much new. Further, before that.
The writing machine.
Somebody says PlayStation 1.
Writing machine, doctor.
What was the first computing machine?
Typewriter?
Sorry?
Typewriter?
Typewriter doesn't do calculation. It's type. It doesn't do calculation. It doesn't calculate anything. You press A, you press B, it will go with A, B. What do you think the first computing machine? Our fingers. Early human, the first machine they used to help them calculate stuff was 1, 2, 3 plus 5 plus 6. Correct. But we figured out we don't have enough fingers. Like my daughter at a certain age, she figured out she doesn't have enough finger to count. So she has to start using something else. This is when the Chinese, sorry, we'll talk about this in 1 minute. This is where the Chinese invented actually this tool. Good. The abacus, whatever they call it. I'm not sure if any of you know how to use it. I don't know how to use it, but it's a way for the Chinese to do a lot of adding and calculation and multiplication in a very nice way, fast way. Good. It's a tool to help them make the calculation easier. Somebody will tell me, Hassan, this is not a computer. I know it's not a computer. I'm not saying this is a computer. I'm saying this is a computing tool. It's a tool that helps us do the math. It's a tool that helps us calculate what's going on. How many kilo I sold today, how many kilo I bought today, how much money I have. You can do that math based on something like this. Good. These kind of stuff, we call them mechanical machine. They are not electronic machine. These are mechanical machine. This is an example of them. So this is a small toy that was very popular back in 1916 to teach kids multiplication. Good. You just move the monkey's leg to the two numbers, 5 times 10, and the answer will show up here. 7 times 10, the answer will show up here. So it's a tool that help you get the calculation. So the computing at that age, at the early years, were actually just a matter of a tool that help us do the math. Of course, math is too much more complicated than this. So Mr. John Napier, he was the first one who started inventing something called logarithm. Meaning, they have let's say they have a math problem. You know how the math problem that they used to give you in high school, like what is the transformation rate of I don't know what, or what is that oval shape, or how do you calculate the area of the circle, or how do you calculate the area of an oval shape? Good. Usually, if I told you how to calculate the area of the circle, what do you have to do? R times B to be R squared, correct? And if I told you, okay, so the circle radius is 5, you have to do like 5 times I don't know what, give me the number. Then if it's 5.342, 5.32, and now we have calculator. Imagine when they didn't have calculator. So this is when this guy started inventing something like this. You guys seen this disk? You played with this disk that teach you verbs in English and word. You turn the disk and then you can see like the verb and their past tense. You seen something like this before? It's similar to it. Good. So this table, for example, will give you the answer for whatever question he's asking. So he moved the stick in a specific way. he get the answer immediately. Of course, it's not a computer. The tool is not doing it by itself. He the one who sat down and he do all this stuff, all these number and calculation, and he give it to somebody as a tool to help him find the answer quickly. Good. It wasn't until the 1643 when actually Pascal, and if you guys know Mr. Pascal, if you don't know him, oh my God, you guys are lucky. If you know him, I'm sure it's just like most of the students in this world swear at him. Him and the Newton, Pascal and the Newton are friends. You know the guy who throw the apple and this guy, they are friends. Okay, that guy is a crazy mathematic guy, Pascal. He have a lot of stuff doing with math. I remember we used to swear at him and his family when we were students because of his calculation that give us headache in the class of math. Good. That guy invented the first calculator. And again, it was a mechanical calculator. It's a calculator look like this, where you turn this thing into 5, turn this thing into 6. So now it's 56. And then you turn this thing into 3, and then this into 2, and now it's 23. And then you start rotating the stick like this until you get the answer. Good. It's a mechanical machine that calculator. But instead of pressing the numbers, you turn this. So this is how the math start getting developed. Good. The first computerized machine. What do you think the first machine that use computing? I don't want to say computerized. Computerized is wrong. It should be computing machine. The first machine that used computing was the loom. You know the loom that they use for making clothes? You know this tool machine? Good. Have you guys played with something like this? This machine, you usually do stuff on it manually, meaning the ladies who do this stuff, or the ladies who do what do you call it? Knitting. My daughters now, they are doing knitting in school. Good. So my daughter comes to me and says, Dad, you have to do 3 up, 1 down. And that will give you this kind of style, textile. And then one time you do 3 up, 1 down. One time you do 2 up, 2 down. And I was like, what? And she keep doing this until she got that nice piece of whatever thing she is doing. So this operation was manual until this guy, Jacoda, he decided to find out a way to do it manually, automatically. So he invented something called the punch card. There's a nice video here that will show you everything. So let's look at it. It's about a few minutes. Oh, sorry. Oh, 1 second. Oops. So this is the netting in general. So he invented a punch card that control the needles of that loom and will let you change the design as you go. Why is it not moving? I'm trying to show you this, but it's somehow stopped. I'll check that image file. Okay, it will just show you how the punch. 1 second, sorry, I got it, guys. I know the PowerPoint is sometimes driving me crazy as well. Not this one, this one. Okay, so he invented a bunch of cards that will get him to do the needle. So you can see it now. 1 second, 1 second. Please move to the next slide. Yeah, image is done. So if you look at the video, the video will explain everything for you. Will show you how the punch card will actually control the needles. Good. Later on, in the year after that, they're still going through the mechanical stuff. Good. They still had to go through the mechanical stuff to invent stuff. So this is the gentleman, Charles Babbage. He invented a machine that actually can do a more complicated level of math, not just a standard stuff. So this machine was called analytical engine. So the machine was actually, as you can see, it's done by hand, and then the numbers and the disks here will move to give you your answer based on the settings that they do to that. Okay, so this is the first machine was done in hand to do a more complicated kind of math. Okay, so we'll go to the next slide. This lady, she's the first lady who created a program, a computer program. She's the first programmer, Ada. So what she did, she was able to write a program for that analytical engine, for this engine. She wrote a program. So that way, if you want to do the calculation, you don't have to do all the settings manually again. You just put the program somehow and you do it. So she's the first programmer in the world, Ada Lovelace. Later, just so you guys understand what's happening in the world, Herman Hollerith, this guy was in America. He used to work with the population count office in America. At that time, in 1880, they used to do that population count in America manually. Good. And then it takes them 10 years until they be able to put all the data together and then produce the number to the government saying, we have, I don't know, 30 million female, 30 million male, we have 20 million under age 5, 17 million above the age of 10, you know, this kind of information. It took them 10 years to do it. So that's why they used to do it every 10 years. This gentleman, he invented the machine. Good. And the machine has some description here. Again, it was depending on something called punch card. Good. But he managed to get the data done in 6 weeks instead of 10 years. Imagine how much difference this machine was able to get for them. Again, this is a 100% mechanical machine. It has nothing to do with electronic equipment or this stuff. He used something called punch card. So you understand what punch card is? It's similar to the stuff that you guys do the exam on it. You remember this stuff that you guys answer the exam on it? You say A, B, C, D. Good? You've seen this stuff. So imagine this. Instead of me asking you to write, you guys write A, B, C, D, I will ask you to make a hole on the right answer. So the guard was saying, for example, is that guy you are counting, is he a female or a male? And he will punch the right hole for it. Is he married or not married? He will punch the right hole for it. How many person in the house? He will punch the right number for it. Good. And this card, they put it in the machine, and the machine, because of the needles, she will be able to start counting how many males, how many females. Good. And give him all these numbers. So these are the punch card. As they don't have a hard drive at that time, there was no hard drive, there was no USBs. They used the punch card to store the data on them. Okay, the punch card in 1890, they invented a summarized punch card, which is a punch card that have a little bit more details on it than the standard one. Like, I don't want to say zip, but they were trying to put as much data on the card as possible. Similar to what we want to do now, trying to zip the files. Okay, this gentleman machine actually had a big company for it. It was a very good business for him because so many people have a ton of information that they want to sort and they don't know how to sort it. Good, how to get the information. So he was having this company called computing, tabulating, the recording company, just for sorting data. That company in 1911, good, it became IBM. So you know IBM, the biggest computer manufacturer headache in the world now. IBM was created on 1911 out of that guy mechanical machine, and their punch card was used up to the 70s. And I remember in the 80s, I saw it in my dad's office, and I told him, "What are you doing with this?" He says, "This is all the information that we are having. We cannot throw it away because we might need it." So they had it in his office. Those punch card was still alive up to the 70s and the 80s. The same principle, even though the hard drive came, but there was some old data and some old machine. That's why some people were still using it. Good. So until now, we're still talking about mechanical computers. Mark I was a project done by IBM in Harvard University. It's a kind of a calculator. It's a calculator machine. You can see the name, automatic SQL controlled calculator. So it's a calculator machine. Good. That is actually do calculation. It's a project done by IBM, and it can be actually programmed. We can actually program it. It was 35 ton in weight and has about 500 miles of wiring, almost like 750 kilometers of wiring. Oh, sorry, 750, yeah, kilometer of wiring. You can imagine how much wiring it has to get the machine in the way you can see it. Good. Let's guess another guess. So this Mr. Harold Icahn, the guy who invented this machine on the 1947 to calculate the stuff, they asked him in a newspaper, what do you think, how many machines do you think the United States will need? Your machine was amazing. It was absolutely amazing. Like the iPhone 11, everybody ran to the market to look at it. Wow, good. How many machines did you guys think he says the United States need when they ask him?
50 million.
50 million?
50 million.
What do you guys think? What is that number in the chat? 10 million. Come on, throw a number there. Let's see who's the one who's like the closest number will win a gift. Okay? Closest number, I will let him go 5 minutes early. Come on, anybody else want to participate in the chat? There's a big difference between 30 million and 3. What do you guys think the number? He says only 6 machines. He thought that 6 of his machines are enough to cover America's need of computers. Yes, Muhammad was the closest for this. Good. So the guy imagined this is how much they were thinking about what's happening in the technology. Good. Now let's stop talking about mechanical machines. Let's talk about electronic computers. So electronic computer, this is when the time starts going through electronic stuff and more electronic stuff. So this guy is very important name to remember. Why? This is the guy, he's a mathematician guy, Alan Turing. He's a mathematician guy. He used to work in the World War II with the British, trying to decrypt the German spy messages through the radio. He was doing this, and I think there's a very nice movie about him on Netflix, about how those guys were decrypting the German secret Nazi stuff. Anyway,
sir, the movie is called The Imitation Game.
Yeah, that's it. I forget the name of it. So this guy, after the war, of course, he had free time. Then he figured out something. He figured out that we can create a code from zeros and ones, which is the electronic computers, they only understand 0 and 1. Good. The computer only understand either there is electricity or no electricity on the wire. So he figured out a way. He wrote a paper in the newspaper, in the research, saying that I can make the computers make decisions depending on their processing, just the zeros and the one. He is the father of the computer science that we are using right now. All the computers that we are using right now are still working on the zeros and the one. Good. He's the one who invented the idea behind the zeros and the one. Good. He's the one who says how we can use the zeros and the one to make games and make computers and let computers think and let computers make decisions and process letters and process everything. Good. So he's the guy who had it. Okay. And there's a nice movie here. It's about 3 minutes. And the guys will explain everything about that guy. I really like you guys watch it. It's very nice. So what was the first electronic computer? So the first electronic computer invented by John and Atanasov. Good. He is again a physicist guy. He invented this computer in the 1939. He was depending on the logic of 0 and 1 by Turner. Good. He was depending on that 0 and 1 system. The funny thing is, up to the year 1973, it wasn't that the first computer. It was the one that was made by 1940 in a different company, INFS. Good. But back in the 1973, the court decided that those are not the first computer, it was him. So 40 years after he invented it, the government decided, or the court decided, that he is the right owner for the title first computer, not INFS. Now, Electronic Numerical Integrated and Computer, this is a company done by 3 different universities research with those 2 gentlemen. Those are the one who made what they call it the first computer. Up to very long time, people were thinking this is the first computer. The reason this is very important machine that those guys made, because it could actually solve something called differential equation. When you are studying math, and if you talk to your math teacher about what is differential equation, your teacher will get very surprised about it and how complicated and how amazing tool it is in the math people. So this computer was able to solve that problem, was able to answer the problem, and was able to solve the math after behind it, which is something amazing. And that's one of the reasons the technology start booming up after that. Okay, this machine Mach 1, good. Sorry, this is the EIN ISECA. It was 1,000 times faster than Mach 1. Good. It has 42 panels across the world, across the room. It was 30-ton machine. It used something they call it vacuum bulb. So the vacuum bulb looked like a big bulb that you guys have, you know, this light bulb. Good. And they have 19,000 of these. Imagine there is 19,000 of these inside the boxes here. And imagine one of them goes bad and they have to go find it and replace it. 19,000 of these. This thing was consuming power of 200,000 watts per hour. That's more than 1,000 machine of today's computer. So that calculator consumed more power than 1,000 desktop that we have today. Good. Again, there was no input or output. There was no keyboard or mouse or screen. It was all reading the data from where? From IBM card and giving the answers on IBM card. Good. Punch card. Then somebody invented a very good idea, which is called store to program. So up to this stage, the way we do calculation is every time you have to redo the settings on the server or on that, or if we can call it a computer, do the settings so we actually can enter the data and we get the answer. Good. So let's say today he wants to calculate the grades of the students. So he will go configure the server, put the student card, he will get the answers. Tomorrow, somebody asking about the consumption of pizza in the state. He will do the front configuration, put the card, get an answer. Then another teacher came, he have to go and do the configuration again. Later, they invented something called store to program. So this is when they find out that we can actually store the commands and the data and give it to the machine, and the machine will give us the result. So we don't have to redo the configuration every time. We just put them on the same card, the command and the information. Okay. These are technically the two gentlemen, Macaulay and Eric. They started the idea, but the one that actually did it is John von Neumann. He's the one who invented this storing the program idea. More details. I ignored this slide. I should have removed it. Okay. Dr. Grace Murray, this lady, she is the one who created the first proper programming language, which used to be called COBOL. COBOL is one of the first programming language back in the 1994, 44, 45. Good. Was one of the basic before Java, before any of those stuff. Good. And she is also the one who invented the principle of debugging. This is something you guys will learn in the programming. When you write a program and the program doesn't work, you will have to find where is the wrong, where is the mistake. Did you forget a comma? Did you forget a bracket? What did you do mistake? That process, you call it debugging. Find the problem. So this is the lady who actually invented the COBOL programming language. Good. The technology started evolving, and then there's something came called the transistor. So the transistor was a replacement for the bulb. And just so you guys imagine the difference between the two, the vacuum tube is technically almost the size of my thumb, and sometimes it was bigger. And the transistor size is less than the size of the rubber end on the pen. So this is much difference between them. So they do the same job, but the transistor is 100% electronic stuff. This is like scary. Good. When that happens, this is when the things start getting smaller. And this is when the things doesn't need 30 ton anymore. It can be actually smaller. Later on, they start inventing something called integrated circuit. So in this small piece in the chipset, now we can put thousands of transistors or millions of transistors. Good. Just to give you an idea, the 1 gigabyte memory that we have in our computers right now, in your computer, you might have 8 gigabytes. Good. Just an idea. 8 gigabytes. Good. If you want to do this, it has 48 billion transistors. The 1 gigabyte. Imagine we didn't invent the transistor and we are still using the vacuum bulb. Can you tell me how much room you will need to have 48 billion transistor, billion vacuum bulb? It will take half the size of Qatar just to make 1 gigaram of RAM. So you can see how much difference we go in this chipset. Good, integrated chipset. In matter of fact, Moore laws, Gordon Moore is the co-founder of Intel back in the 1968. He's the guy who helped creating Intel. They asked him, what do you think about the ICs? He says they will double in the capacity every 1.5 years in their ability. And this is some sample here. This is the processor from Intel, which was named 8086 back in the 1976. Good. That processor, and this is the processor that we usually teach machine coding in the engineering university about it, and many people are using it in the schools. It has 29,000 transistors back in 1976. In 2018, 40 years later, it has 3 billion transistors. You can see how much more and more spaces and how much more and more complicated the electronic stuffs are going. The i7 processor in your laptop right now, or the i5 processor in your laptop, might have even more than 3 billion, might have 4 billion or 5 billion. And that's just your laptop, which is honestly, it's not that impressive chipset anymore. You have to go see what's happening in the big servers machines. Good. IBM first personal computer came in the 1981. Good. It had a Microsoft DOS operating system. It has a DOS operating system. So what is operating system then? So we'll talk a little bit about operating system. So operating system started up because these computers, they need something to let them run. That's what they call it, operating system. And we'll talk about it later. No worry about that now for now. But that time at the beginnings, back in the 70s and the 80s, good, in the beginning of the 80s, they were using something called command prompt operating system. These are operating systems that do not have nice graphic or nice icons or nice desktop. No, it's a black screen like this. So for example, here is, I will show you the, 1 second. Open. So here is my Unix server. You see? This is how the Unix works. So if you install Unix on your machine, you don't get icons, you don't get desktop, you just get what? Black screen like this. And everything you have to do, you have to type the command for it. So you have to memorize these commands. This is the Unix screen. Let me show you the DOS one from Windows, so it will be easier for you guys. Here is the Windows command screen, and I'm going to show you the Windows one next to each other, so you guys can see the difference. So when you guys work on Windows, you technically are working on iconographic interface, meaning you want something, you double click on it. You want to delete it, you right click on it, you click what? Delete. Good. You want to make a new folder, you do it. Here, they don't have this stuff. You want to see what is inside the C drive? Here it's simple. Just go double click on the C drive. You will see it. Here, no. There is a command that you have to type. You have to memorize that command. The command called dir. Of course, you don't have to memorize it in this class. Good. But I'm talking about me working on DOS back in the 1990s. I have to memorize it. So dir, press enter, boom. I got the list. So it's the same list. You see here is Fifi, Ghost, Intel, ISO, Fifi, Ghost, Intel, ISO. Good. If I want to create a new folder called Fufu, here I just right click, new folder, and call it Fufu. Okay. Here I cannot do that. I have to do a command called what was it? MD Fufu1 dir, and now I have Fufu1 and Fufu. You see? If I want to delete it, Forget all of it. DRD 441. Now dir. Hey, 441 got deleted. So this is what we call it command prompt operating system. Good. DOS, of course, Microsoft DOS, almost nobody use it, but we still use it, even though nobody in the world, I mean, your dad, your mom, your friends, the non-IT guys, the muggles, as we call them, the non-IT people, they don't use this operating system. We IT people love this stuff. In matter of fact, in one of your future courses, you have to learn how to use the Unix system. Good. You have to learn that. It's one of the classes. And it's one of the very, very important systems that you guys have to learn and have to use. And heads up, it's critical for your life. Don't let your friend tell you it's a stupid system and the teachers are giving it to us just to bother us. It's one of the very important systems that you guys have to learn in your life. And everybody will need to know how to handle it, at least at the beginner level. If you are going to server team, you need to get more and more about this. But for the rest of the guys, you have to learn how to use Linux, at least as a beginner level. Okay? I'm sure when you go to the Linux class, the teacher in the Linux class will try to convince you why it is better. But honestly, it's very, very good. So back in the 90s, in the 80s, sorry, and the 90s, this is when Apple started their operating system, Macintosh OS, and Microsoft Windows launched their Windows, and IBM launched their Icon. Again, they call it graphic user interface. It's an operating system, but instead of typing the command and memorizing the command, you are using the mouse to click on stuff. Imagine how our life would be miserable if you have to teach your father and mother how to use the mobile phone using command. Or that if you want to send a message, you have to type SMS space, then you type the name of the user that you want to send to, Hassan, and if there is a space, you cannot type it, so you have to type Hassan star Ode, so you can do it, and then you have to put another star, then you put a space, then you have to start the message between two quotation, and then you have to do this, and I will not use the phone. Yeah, so that's why graphic user interface was very, very important. In the 60s, the idea started. In the 70s, Xerox was very active in that part. Steve Jobs did his operating system for the Macintosh machines back in the 1984. Good. Bill Gates and Paul Allen did it for the Microsoft Windows, and they had a huge fight in the court between them about who have the right for it. Anyway, IBM have their operating system. So this stuff starts coming as we go. So that's why we have this all operating system right now.
Sir, actually, with the Xerox story, the fight was about a mouse, the invention of the mouse, and Xerox was the one who invented it. But then Steve Jobs stole the idea, and then Bill Gates stole it from Steve Jobs. So it was all like a huge fight about this invention.
Yeah, the mouse also, they had a huge idea about it. I don't know the name of the guy, I didn't write it here. Good. So there is a huge fight. Not only this, there was a huge fight not about the mouse only. It's a huge fight about the icon itself. The idea of you double click on something instead of using command to open it. That's the idea. They were fighting about it, and they had a huge court between them. Good. The input devices, as you know, computers need to have data. You need to receive data. You need to get data. So these are the input devices. Good. The mouse was invented back in the 70s, and it was very important tools because the old mouse was a small ball running, and as the ball ran, there was like two disks. Here you can see those two disks, and these two disks will tell you that the mouse moved to the right or moved to the left or move up or move down, and this is how the cursor moved in the screen. This is the first actual mouse that the guy did from wood. Good. This is the mouse that has the ball. We used to use them up to like 2000, I think. And every few days, you have to take the ball out and clean it from inside because all the dirt, looks like a vacuum technically. All the dirt that you have in the floor and all the food that you eat on your table will technically end up inside the mouse. So you have to clean it every few days. Yeah. Nowadays, alhamdulillah, it's all laser. We don't need this, but anyway, the idea is there. The network, the Ethernet, the network cable was actually invented by Xerox. Again, so Xerox invented a lot of stuff, but nobody knows about it. Everybody talk Apple and Windows. Xerox actually was more active than those guys. Good. So they invented the network, the idea of connecting to computer with a network, and from that, the internet came after that in the future. So Xerox was the one who actually invented the Ethernet. Good. The internet The internet started as a military project for the Department of Defense in America. Good. The idea behind it was they needed a way that all their computers can talk to each other, even if somebody somehow bombed them, like the Russian came and attacked the line between New York and Washington, let's say, that no, they need the network to work. So New York can talk to Philadelphia, and Philadelphia talk to Texas, and Texas talk to Washington. That's fine. We get connected. So this is where the idea came from. Good. The United States started this back in the 60s during the Cold War. Later on, universities joined in. Universities find it's very useful. It's very helpful. And then the United States give it out from their control, from the defense to the National Science Foundation. So Ministry of Defense says, oh, that's no longer a military secret. You guys can use it as civilian. This is when the internet actually invented back on the 80s. Back on the 80s, we didn't have web pages, but there was abilities to the computer to talk across each other, across the network. Good. The web pages came back in the 90s when somebody invented the hyperlink. You know the hyperlink on the web page where you click on it and it will get you to another web page. Invented back on the 1990. Mosaic was the first browser back in the 1993. And again, somebody will think the first browser should be Google Chrome or Firefox or Internet Explorer. It's not. It's a Mosaic. Good. Of course, Microsoft, as usual, steal the idea. Apple steal the idea. Chrome get the Google get the idea. Good. In 1998, this is when the Backrub started up. It's a company which end up to be Google. Good. Wait, not this slide. So Backrub is the company that started between those two gentlemen, and then they changed it to what? To Google. They changed the name to Google. This is when the Google came up. Good. I didn't play the game. Okay. So somebody from the news reporter was talking to Bill Gates back again in the 70s and 60s, and he asked him, how much RAM do you think is enough for a PC? He says, Bill Gates answers 640 kilobyte, not giga, not mega, 640 kilobyte. Good, is more than enough for anybody. 640 kilobyte. Right now, my laptop have 16 gigabyte of RAM, which is almost like what? 1 million times more than this. At that time, Bill Gates thought nobody need more than 64 kilobyte. Here is some more dates. Apple started in 1984. Microsoft launched their Windows 3 in 1990. 92, they launched Windows 3.1. 96, Backrub was created. 97, they named it Google. 2000, Bill Gates launched Windows 2000. Good. 2001, Wikipedia got started. Windows XP came up. Google purchased Android. So Android wasn't done by Google. Google just bought it from somebody. Good. YouTube was created. Again, Google went out and bought YouTube. Okay. Nintendo released the Wii. This is when the computer starts shifting from just normal computer to gaming. 2007, Apple launched their iPhone. They launched their iPad after that. And all this stuff start coming up. Good. So this is just general about how the technology start moving in the following days. Good. Anybody have any questions about this?
No, sir.
So the next few slides are a game for you guys to play at home, to practice. It will show you the photo, and then we'll show you the details about it. So there's a few photos about the people who came up in our presentation. Try to remember the photo and the name and what did they do. Good. So it will take you a few minutes just to get you guys some kind of practice to know the names and to memorize these names. Okay. So today's computer, of course, today's computers are huge different from 10 years or 15 years ago. You have desktops, all-in-one desktops, you have laptops, you have the tablets, you have the smartphone, the smartwatch. Now we have smart homes. So smoke detector, door sensor, monitor sensor, motion sensor, everything goes around as smart devices these days. Even the human now, smart ring with smartphone, with smart finger, everything you can get into your stuff. And this is how technology advancing right now. Good. So all these technology and servers are growing up. It's more photos. Good. In general, computers are all the same. All this equipment, I don't want to name computer. Like the smartwatch is some kind of computing machine. The smart TV is a computing machine. The smart dishwasher is a computing machine. I don't want to name them computer because sometimes people focus computer is a desktop. No, all these computers, all this equipment, they're almost the same. They have different speed, they have different capacity, they have different accuracy, and they have different kind of types or quality of work that they present. Computing progression, how did the computers shifted in the world from 1971 to today? So in 1971, we started with 1,000 computers in the world. Up to today now, we have 20 billion computers in the world. You can imagine in those 40 years almost, good, how many computers are getting in the world right now. And the guys are expecting now in the next couple of years or in the next 5 years, these numbers will double in 5 or 6 or 10 times even. Once the smart equipment starts spreading actually in the house, you will not be able to stop it. Smart doorbell, smart iron, smart washing machine, smart freezer, smart fridge, smart TVs, smart I don't know what. Good. All this stuff is coming, and sooner or later, especially when the 5G come up in a proper way, you technically will have everything smart at home. Good. So the computers are going more and more. The last thing, there is a something called supercomputer, or as they used to call it, high performance PC. Good, high performance PC. So the computers that we have right now at homes, they are super high performance compared to the computers that were there 30 years ago. Good, but still, sometimes the amount of data that we have to process are so massive, it will take you a ton of time to finish. I know one of my friends, he's in Qatar University in the physics department. He is a teacher in physics. He was doing research. So he was collecting data from some of the sensors. I'm not sure what the experiment was, but he was anyway collecting data for almost 2 years. Good, from some kind of thing happening in Qatar. Anyway, so after 2 years, he had to run some statistics on this data to find out all these statistics number from this data. And the data was about 4 gigabytes. You can imagine how much data is that? How much text file? It's a text file that is 4 gigabytes of data. Good. And he ended up making fun of me. He said, Hassan, I need a high performance PC. I told him, like, yes, wait for Qatar University to build one. Qatar University has a project to build one. So, of course, he went out and he rented a high performance PC from Germany through his relation and research with them. They rent it per minute. So you can rent it for 5 minutes or 10 minutes or 1 hour or 2 hours. So anyway, they give him time slot. He upload his data, he prepare it. When the machine is ready, he run his analytic on it. When we run it on his PC, and he have a very nice PC at the office, the expectation was like 5 years to finish the calculation. When he ran it on the high performance, it took like 1 hour and a half to get the results. So this is what we call it, high performance PC. Qatar University has a big project about getting one in Qatar. And believe me, those are not easy. It's not a piece of game. It's a huge machine. Good. And they were planning to do it at Qatar University. Unfortunately, they hired somebody who knows how to do it. They hired a few people. They were training people about it. But then because of the massive cost of it, things were slowing down and they postponed it for another few years. So in a couple of years, they will do it again. In Saudi Arabia, there is one. In whole Saudi Arabia, I know there is one only. In Germany, there's few. In Egypt, I don't think there is one in Egypt. Good. So that's how big it is. Okay. But this is for something massive calculation. Okay. Last 2 slides. Computer versus human. There was a say that computer will never beat a man in chess. That was true until 1997 when the Deep Blue computer actually managed to beat Kasparov in chess. Kasparov was the genius guy, the world champion in chess. Nobody was beating that guy. Good. The computers played against him in the 98, 99, 96, 95. And then finally in the 97, they beat him. The computer managed to beat that guy. It was a huge, amazing advancement for us, not just because the computer beat the human, it's just about the idea that the computer can think and strategically think and advance the game. Good. But there was some people who doubting this, that, oh my God, Terminator and Arnold Schwarzenegger will come back to destroy humanity because of this. At the same time was the movie Terminator coming up. I remember those days, people were like, Hassan, what do you think? Are the computers going to take over and destroy the world? Like, yes, definitely. And we are IT guys, will be their slaves, but they will not kill us. Everybody else will die. Good. And of course, again, that was the technology at that time. There was also saying that computer will not be able to understand your speech and answer you until 2011, when Watson, which is a computer, participated in a game, in a show game, where the announcer or the presenter of the show will actually ask questions and the contestants answer and win. The computer win. This is the era when the technology of recognizing voice, recognizing command, this is what makes Siri a true. This is what makes your TV, you are able to talk to your TV now, or you are able to talk to your car, or you are able to talk to your mobile. This is done in 2011 when that guy actually managed to do it. Good. Back in the 1965, there was a lot of chat about, will the computer ever be smart? One of the guys, this guy IJ Good, he says, until the day we teach the computer how to win the game of Go, it's a Chinese game. Game of Go look like Dama, but it's so much more complicated and has a ton of strategic. This game, it says it's way much harder than the chess. He says, once we have this, this is when we can say computers now understand strategy, and that we designed a learning program for the computers, not only to do stuff, but to learn stuff. So the computer can teach himself after that. This is happening in 2016 when the AlphaGo actually beat the world champion Lee Solden in 2016. So the computers are getting there. All these challenges were done that, oh no, the computers will not do it. We are doing it. Good. Let me just stop here for a second. Pause that.